Hello, Algebra 2. It's been quite a while since we had class, so I thought I'd make this video to go over the current topic. The current topic is topic 14, roots and zeros. And I might go kind of quick through these problems because it's a video and you can always hit the pause and rewind. So the first type of problem you'll see on the assignment is a polynomial like this. And this is in factored form because everything is multiplied out. These are the easiest ones to solve. So if you want to find the roots, we're actually finding when this thing equals 0. And basically just set each part to 0. We see x equals 0, x minus 1 equals 0, x plus 2 squared equals 0. And these are easy to solve. Well, there you already got one answer. And from here, if you add 1, you get x equals 1. That's an answer. And here, don't let the square mess you up. You could just take the square root, and really that just drops out, and we just get x plus 2. And the square root of 0 is 0. And then really, when you move the 2 over to the other side, it becomes a negative 2. And those are your three solutions, right? 0, 1, negative 2. In Delta Math, when you enter the answers, just put a comma in between and you'll get another, a box will appear to allow you to put the answer in. The second type of problem is solving by factoring. So these are not in factored form. It doesn't look like that first one. And the game plan is get everything to one side of the equation, right? So we'll add 5 to both sides here. It just so happens that when you do that, you lose your constant term. You know, that zeroes out, and this just equals 0. And because you only have two terms, you got to look for a greatest common factor. And guess what? We got one. We have an x in each term, so we factor that out. That's called a GCF, greatest common factor. And when you divide by x, you're left with x minus 8. Now you're factored, and then you just set each of these to 0, just like you did in the first problem. And it's pretty trivial from then. You get your two answers, 0 and 8. Okay, moving right along. Another of the same type of problem, factoring. And again, same deal. We want to set this to 0, so we got to subtract x from both sides. We want to add 5 to both sides. Okay, so on the right we have 0. That was the game plan. When we bring down the x's, negative 9 minus 1 more is negative 10. 19 and 5 is 24. A trinomial, 3 terms, we factor into 2 binomials. Because it's x squared out front, I need x times x in the first position. Now I got to multiply to 24 and add up to 10, so I kind of go to the side here. I list all my factors of 24. There's 3 times 8, 4 times 6. Because I have a plus here, the signs have to be the same. The minus here tells me they're both negative. And the only way this shakes out is a negative 4 and a negative 6, because minus 4 minus 6 will add to negative 10, but it will multiply to a positive 24. But then when I set each of these to 0, in this first position I get x equals 4, and this x to 0 it out would have to be 6. So I have two solutions, 4 and 6. All right, just two problems left. One involves the rational root theorem. The rational root theorem, we list the possible, this is the key, possible rational roots. So the possible roots here, what I like to do is just kind of draw this little fraction bar, and basically it's anything that divides the constant term would go up top. So really this 5 I put up here, and anything that divides this leading coefficient goes on the bottom. That's a 3. I kind of ignore the negative sign, right? So I guess if I'm color coding this, the 3 came from there, the 5 came from the last term or the constant term, and all I got to do is kind of list the factors of 5, and there's not many, it's just 1 and 5 because it's a prime number, and the factors of 3. So my possible roots, or my possible rational roots, and on Delta Math, this is going to be a multiple choice question for sure. It's plus or minus. 1 divided by 1 is 1. I take all the combinations, right? 5 divided by 1 is 5. 1 divided by 3 is 1/3. And what else is left? 5 divided by 3. So 5/3. So there's and it could be plus or minus, right? So this would be your answer to the possible rational roots. Really, it's only determined by the first term and the last term. Okay. Now this last type problem kind of puts everything together. It says use synthetic division to find all 3 solutions. Of course, you remember synthetic division, we bring down these coefficients. And the thing is, we did not give you a multiplier. So we have to take an educated guess as to what we'll use. And how do we guess? We look at that last term. We need something that divides 1. Lucky for us, the only possibilities are 1 and -1. So I'll try 1. And of course, you remember this algorithm. Bring down the 5, multiply, add down, multiply, add down, multiply, and I zero out. You know what that tells me? That tells me that this 1 is going to be one of my final answers. Like that's a solution. So I got 1 of them. I only need 2 more. Lucky for me, I'm left with this quadratic, 5x squared plus 4x minus 1 equals 0. Because one of the terms is 1, I can just factor this pretty easily. To get a 1, I need 1 times 1. To multiply to a 5, I need 5 times 1. And to get x squared, I need x times x. And then if I want to add up to a 4 in the middle, I better go positive 5x minus 1x. Remember that middle term is determined by the cross products, the insides and the outsides. So it would be 5x minus x is 4x. So I know this looks a little bit tricky, but we set each of these to 0. And here I would get 1/5 as an answer. And here I would get -1. So if I was to write down all my answers, 1 was an answer. That was my original multiplier. 1/5 was an answer, and -1 was an answer. So I know I went quick. So go back and kind of look at them, try to work through them, and then get to that delta math, see how many you can do. But we'll continue these problems in class on Thursday and Friday.